F322 June 2012. Question 6. This is that last question on the paper, which generally looks at analysis, and you've got to try and identify which kind of molecule you've got from an infrared spectra. This question's got a little bit of a twist on it because it wants you to know all about halogenoalkanes. So we've got a student here who's hydrolyzing bromopentane and chloropentane using sodium hydroxide. So key to this question is that you know this reaction. You should know what this forms, and you should also know the mechanism from which it forms. So just stop for a moment. Yeah, so haloalkanes with sodium hydroxide forms alcohol, and it is nucleophilic substitution. You've got that OH minus that substitutes from the carbon, which, because the halogen is more electronegative, becomes delta positive. The first question here is a fairly straightforward rates of hydrolysis. So state and explain, and perhaps I'll highlight those. So you've got here state and explain. So you've got to say what the difference in rates of hydrolysis between the bromopentane, one bromo, and the one chloropentane. So here we can say, first of all, to state, one bromopentane, here we go, one bromopentane reacts, does it react faster or slower? Reacts faster, doesn't it? And then for your second mark, why does it react faster? The C-Br bond. And notice I've been specific about which bond. It's not good enough to say the bromine, the chlorine. It's the C-Br bond is weaker, easier to break, any of those. And that's enough for your marks. You can obviously do the reverse argument, so chloropentane reacts more slowly because it's got a stronger bond. You could also mention here it's weaker and so requires less energy to break, and it might be worth putting that in, as we never quite sure what the marks will actually be looking for. Though on this kind of question it's fairly standard. It says state, so you say that bromopentane reacts faster, and then your explanation, the C-Br bond is weaker. You can say that there's less energy required to break it. So that, for that question, would cover your 2 marks. Okay, part B is where this question really gets down to business. So a student wants to determine the structure of an unknown isoalkane B. She knows that the molecular formula of B is C4H9I. So she heats B with aqueous sodium hydroxide. And as we've already said, we know then that C, if it's produced from a reaction of an isoalkane and sodium hydroxide, should be an alcohol. And it's telling you you've got iodide ions as well produced, so you know that a substitution has occurred. Here then, draw all the possible structural isomers of B. So I'm going to do this in skeletal formula. We've got long chain, well, we've got 4 carbons, so 1, here we go, 1, 2, 3, 4, carbons in a row. I've got to put the iodine on, so a bond to the I there, and I have here 1-isobutane. Then same again, 4 in a row, 1, 2, 3, 4, and I'm going to put my iodine on number 2 this time. So I've got 2-isobutane. Now, can I have 3-isobutane? The answer there is no, it will just become 2 again, because I'd start counting from the other end. Remember, you have to have the lowest number when you're naming isomers, so the lowest number of the position on the carbon chain. So there's 2 isomers. I've got to have all possible structural isomers. This question, I can't see on the screen at the minute, this question is worth 4 marks, which suggests that there'll be 4 isomers. Once all the possible isomers, it will be 1 mark for each. So that number of marks can often suggest to you how many isomers you need to be drawing. With a 4-carbon chain, what you can do is take 1 carbon off the end and put it to become a methyl group. So remember, if you've got a carbon chain, we've got 4 carbons there. If I take, change colour, if I take this one off, I can put it in the middle there. I've still got my 4 carbons. What I cannot do, remember, is try and put it on the end and pretend it's a methyl group there, because that is just increasing your chain length again. But here I've got a definite branch if I put it on number 2. So drawing my second set of isomers, then I've got 1, 2, 3, that's my chain. I have my branch for my methyl, and I can put my iodine on here, number 1, and I can do the same structure again of methyl propane, and now I'll put my iodine this time on number 2. So I get 2-iodo-methyl propane. So those are my 4 isomers there. Now we get down to the real part of the question here, because what this question is now going to ask you to do is identify which one of these isomers you're going to react first to make C, and then, as we'll see in the question, D. So just looking back at the start of this question, the student heats B, which we know B is here. So we've drawn now the 4 possible isomers of B. Heats B with aqueous sodium hydroxide, a reaction mixture forms containing organic compound C. So we've discussed that C is going to be potentially C4H9OH. From our knowledge of our reactions of haloalkanes with sodium hydroxide, we're thinking that that's going to be the compound C. But again, this is B, it could be any of these, and so compound C, which is going to be an alcohol, could be any of these where the I has been replaced for an OH. What our job is going to be now is to work out which one is actually being reacted. So moving on down, I think there's one little question before we get to do that, which is, what is the molecular formula for compound C? We've said already here that it's going to be an alcohol, but the key here, not to lose the mark, is the fact that this is molecular formula. So I have to write individual atoms without splitting anything up. So I've got C4H10O. So let's get some more information about what the student is going to do. So the student purifies compound C and splits it into two portions. And I'm going to try and draw this out. I think there's a bit of a flow diagram at the bottom here. I've not got much room. What we've got then, we've got starting, we've got B. Let's do it up here. We've got B, which is C4H9I. We've turned B into C, which we're saying is C4H10O. We know it's an alcohol. Now, C then is split into two portions. So we've got a portion there and a portion coming over there. The first portion of C is heated with sulfuric acid, and the product reaction is methyl propene. So we're given methyl propene. All we have to do is try and draw that out. So methyl propene, it's got 3 carbons. So 1, 2, 3. And I'm doing this in skeletal just because the chances are my pen will stop working. It's just quicker. And I've got a methyl group on there. So there's a methyl there. And it's propene. So I must have a double bond as well. There. So that's what that would look like. If you're drawing it in displayed formula, what you've got to be careful of course, is that you get the right number of hydrogens. So on this carbon, you'd have 2 hydrogens. On this carbon here, you've already got 1, 2, 3, 4 bonds. So this carbon wouldn't have a hydrogen, and this carbon would have its normal 3 hydrogens. So that's one portion. We've been told with concentrated sulfuric acid, we get that product. Then the other portion of C, she adds to acidified potassium dichromate and heats the mixture under reflux. So here we've got reflux and we've got acidified potassium dichromate. What sort of reaction is that? Oxidation. Brilliant. So here we've got oxidation. This, I've forgotten to say, isn't it? Concentrated sulfuric acid, it's produced from an alcohol, an alkene, so you have dehydration. So here in this one, oxidation under reflux, and the product of the reaction is compound D. Now, we need to know a little bit more information about compound D before we can start doing anything. And the key bullet point here is that over the page, we've got compound D as a mass spec. So I'm going to go over the page. What you've got to remember is here, we've got a choice of 4 isomers that the I gets replaced by an OH and then becomes a dehydrated alkene in this case, and something according to the mass spec here. Before I even look at the mass spec and try and answer this question, if I've got this branch here, can these be straight chains? Can I make, from the reaction sodium hydroxide here and with sulfuric acid here, can I make a straight chain branched? And the answer is no, I can't. So if I just go back up for a second, it means in this question both of these blue isomers are being ruled out, because if I've got methyl propene, I must have started with a methyl already. So I'll come back to that over the page. So from over the page, I'm thinking, and this is not my answer to the question, it's just my thought process, I'm thinking that B could be either this isomer, oh, I don't really want to draw that like that, or this isomer. So it's either 1 methyl propane, 1 ido methyl propane, or 2 ido methyl propane. And so C, I'm thinking, is potentially, because the iodine is being substituted by an OH, that I've got either this alcohol or this alcohol. And now I'm going to have a look at the infrared spectra and try and determine the structure of D. So on the infrared spectra, I've got here, oh look, perfectly from my data sheet, 25 to 25, I think I've gone a bit far there, haven't I? 25 to 3200, I've got a very broad peak here. This is indicating an OH of a Cu group, and that is confirmed by this peak here, isn't it? Which is between your 1650 and your 1740, which is your C double bond O. So I've got that confirmed. So I know now, and again, I'm not formatting my answer completely yet. I know that D is going to be a carboxylic acid. Yeah, this is where it all goes horribly wrong, isn't it? I've been talking too long. So D is a carboxylic acid. Key to this then, before we go into look at actually writing this down, is that if you look at the two possible isomers that we've decided that C could be, you've then got to make the decision which one of those, if it was oxidized with acidified potassium dichromate under reflux, would produce a carboxylic acid. Look at C, and if you need to, draw it out in displayed formula for yourself. 3 carbons in a row with a methyl group off number 2. If you classify this, the OH is connected to a carbon that is connected to 3 carbons. So it's a tertiary alcohol. Tertiary alcohols do not undergo oxidation. So this is not our C. Isomer C has to be, because we've got methylpropene being produced in dehydration, we know we've got this branch. Here we have a primary alcohol, that carbon there attached to only one other carbon. So primary alcohol. Primary alcohols, when you oxidize under reflux, produce carboxylic acids. So we have our isomer C here. So B, in fact, will be, and this will be marking points now, B must be this isomer. That, and I've lost my cursor here. Oh, it's back again. C is definitely this one. So D must be the carboxylic acid of that alcohol. So if I just draw this one out here, if it will let me, I've got 1, 2, 3. I have my double bond O, and I have my OH, and I'm sorry, I can't see my cursor, my methyl group there, like that. I might try and redo that, sorry. I have my methyl group coming off there. So that would be my answer for D. Now, because I've got this pencil here, and it asks me to link the evidence to my explanations, this is how I'd go about writing my answer. So I've identified my 3 isomers, which would be a mark each. I then go to say, from the spectra, standard, I identify wave number, bond, and I identify that first, that group must be a carboxylic acid. So from the table, I've identified, I've shown where I've got that piece of evidence from. Then to say why I think it's a branched isomer, which we've been saying before, B and C must be branched because methyl propene is produced by the reaction with C. So I cannot get a branch I can't get methyl propene if B or C is a straight chain. There's just no way I can do it. And thirdly, I can say, in addition, C must be a primary alcohol as it oxidizes to produce a carboxylic acid. So I've stated the reasons why I'm saying the things I'm saying. I've got my 3 isomers identified, I've used the spectra, I've used the fact that methyl propene is being produced, and I've shown that I know about the oxidation of alcohols. Now that's full marks for that question.